Hello guys, welcome back to our channel. By the way, I'm Judge Matthew De Leon and I will be explaining the components list and their purpose. We have 5 components such as Arduino Nano, Mini OLED display, jumper cable anemometer, and breadboard. First, we have the Arduino Nano. It is a compact microcontroller board based on the ATmega328B, offering full Arduino functionality in a smaller form factor. It has an analog input pins for reading sensor data and digital output for controlling LEDs or display. Its purpose is to process the analog signal from the anemometer, calculates the wind speed, and controls both the OLED display and LEDs to visually indicate wind intensity levels. Next, we have the Mini OLED display. It is a small monochrome screen that communicates with the Arduino via 12C. It can display text, numbers, and basic graphics using libraries such as Adafruit GFX and Adafruit SSD1306. Its purpose in our project is to display the current wind speed readings in meters per second, allowing users to easily monitor changing wind conditions and identify potential typhoon level winds. Next, we have the jumper cable It is a flexible insulated wires with metal connectors at both ends for making quick and solderless circuit connections between components. Its purpose is to connect the Arduino Nanos to the anemometer, OLED display, and LEDs, ensuring reliable power, ground, and signal transmission across the prototype circuit. Next, we have the anemometer. It is a wind speed sensor that measures how fast air is moving. It typically outputs an analog voltage that increases with wind speed. Some models use rotating cups or a turbine that generates a proportional electrical signal. Its purpose is to detect and measure with wind speeds in real time. The Arduino reads its voltage output, converts it to wind speed, and uses the data to determine the severity of the wind, helping simulate typhoon detection levels. Lastly is the breadboard. It is a reusable platform for assembling circuits without the need for soldering. It allows components to be easily inserted, repositioned, or removed during testing and development. Its purpose is to provide a neat and organized surface for connecting the Arduino Nano, anemometer, OLED display, and LEDs, making the prototype modular and easy to troubleshoot or improve. That is all, and thank you for listening to our project.
Good day everyone, welcome back to our channel, and today we will be making our last project, which is Typhoon Detector Prototype. So let's get started. Ano?
Hello everyone, welcome back. I'm Zanceles Bardos and welcome to Arduino project, which is the code right here. So I'll be starting now, which so in here we have two libraries. One is Adafruit SSD 1306, which is used to power the display for the OLED. So here we have defined screen width 128 by 64, which is the width and the height, and the LED reset. So here we use the method and display the variable here with the height, with the width, the height, the variable wire, and LED reset. So we have a constant here that is for the anemometer, which is A0. And then we have the float for voltage and how much voltage is in, and the float is this float is for wind speed, so it's at zero point 0.0, cannot go negative. So we have two integers here. We have green and red. These are the pins for the anemometer. I mean, these are the pins for the project. Next up, we have setup display dot begin, which is this one. This one is setting up the OLED display, and then delay, I mean slight delay, it clears the display, it displays the whole screen as white, or rather just the text. So next one is the pin modes, green and red, which is 2 and 9. I put it at variable so I can switch it however I want without going through the code and such. We also need to have digital right, green and red to low, so that they don't turn on like automatically. So now we have the loop, which is arguably just pretty short. So now, so here, so here, so here we can read the analog voltage from the sensor, which is INT raw value analog read analog pin. So voltage is equal to raw value divided by 1023.0. This value is taken from the model itself. There is a document about this variable. Never mind. Basically, this is the formula to get the average uh, wind speed. I mean, it's the formula for wind speed. So the raw value is divided by 1023.0 and times by 5.0, and then it converts the voltage to wind speed, which adjusts it by point. The voltage is divided by 5.0 times 32.0, and then we have the wind speed. Next, it clears out the display first before doing anything else, and then it sets the text size to 2, which is at least a centimeter or 2 centimeters. I don't really know how big it is, but I haven't really, what do you call this? I haven't measured it. What is that? So, the display cursor, this is the X and Y of the text. This is where you'll be putting the coordinates of that text. And then it displays anemometer. This one displays as wind speed. Again, is set at a certain point of the display. And then the text size is always 2. It's default, but I didn't put it as a variable because I don't really need it. And then we have here right next to, or actually, the wind speed is at the bottom, right? Oh, sorry. Here we have the meters per second, which is showing the speed of the anemometer in which how fast in which is in which it checks how fast it's going. Ulol, iniwan niyo ako. Okay, moving on. We have here a delay for all of that. So it first it displays everything within this, and then it has a slight delay, so 1/10 of a second, and then checks for the wind speed for the LEDs. So here, if the wind speed is less than 5, it will output green, only green. And then if the wind speed is equal or greater than, but is less than 10, it will not output just green. It will now output only red. But if the wind speed is extremely high, you can just set uh, the wind speed. If the wind speed is extremely high, it will flash over and over again, in which this will happen. This code here is for the LEDs flashing over and over again. And if it detects that it's lower, it will stop flashing and then just go back to the light, in which it would be just red, and then going down one more level it is green. So that's about it. Thank you for listening, and I hope you enjoyed. Thank you.
Nama ko. Kailangan mo nama ko. Ito yung nama ko. Yung ano. Yung kaya mo ito. Yung ako lang. Sige. Tapos ano. Ito yung